Okay, when I think about math, I think about describing math in these four different ways. So this is, the math description could be verbal. So this is like the vocabulary where we say we rotate or we reflect. It could be graphic, so that's when we use the coordinate plane, or this is a graphic right here. Or if we wanted to say like 5 plus 4, this is a graphical way to describe that. Okay. Then there's the numeric. Numeric is to use these special symbols that we've come to call numbers, right? And then there's the symbolic, which we use in general terms, and a lot of times it's algebra. So if we want to represent a number by a letter, we might say that adding two things together could be, the order doesn't matter, or something like that. So these are different ways to use math descriptions, and we've talked a little bit about our verbal descriptions with rotations and reflection. We've done some graphic, we've done some numeric in the coordinate plane, graphing one point to the other, doubling it, or cutting it in half. But now I want to talk about the symbolic representation of these. So symbolic representation uses this special notation, and I want to introduce you to this. So for reflection, we use this letter R with a subscript, and the subscript says what line we are reflecting across. So in this case it's the x-axis. So R sub x-axis is of this point, so we're going to reflect this point x, y. So we're talking about some general point, x and y, and it could be anywhere. Then the result is this new point, right? So let's just do an example. So if I took this point right here, 2, 3, and I reflected it over the x-axis, we already know how to do that, right? It's 3 away, so it would be 3 away on this side. And I end up with this point, 2, -3. Now, let's say I started with this point, -5, -2. If I reflected that across the x-axis, I would end up with 2 away and 2 away, so this would be -5, +2. And you would see that after you do a lot of these, you end up with this result, that if you take some coordinate, x and y, when you reflect it, you get the same y value that you started with, but you get the same x value that you started with, but the y value changes sign, right? So if I started here, I still get -5, but my y value changes sign. So that's what this means right here, x comma -y. Okay, so that's reflections. We're not going to worry about point reflection. Jump to translation. So translation, the notation is to say T, capital T, sub H and K. So T sub H and K. So what if I start with this point here, 2, 3, and say I want to translate by a certain vector. We'll say that that vector goes 3 in the x direction and 2 in the y direction. Right, so it's going to translate by that amount. So from here, this point translates 3, 2 to there, and the new point would be 5, 5. Okay, so in general, how does it change? Well, what I did was I just added 3 to my x value, right? I went from 2 to 5, and I added 2 to my y value, right? So this is T sub H and K. If I start with an x, y coordinate, what I do is I just add on my translation vector in the x direction. So it's x plus h, comma, and then whatever my translation into y is, I'm going to add on to my y value, so y plus k. Okay, so this one was r sub x-axis, and this could be of some point xy is x negative y. So I could do other reflections across other lines, like if I reflected across x equals 1, right? And then I'd have some other relationship. So that will leave to you to figure out. Rotations. So rotations, we use capital R before we use lowercase r for reflection. So this is reflection, translation, and this is rotation. We use capital R, and then the degrees that it will be rotating. So let's say we rotate 90 degrees, and we usually think of it in a counterclockwise direction of xy equals some new point, right? So if I started with this point right here, 5, 2, and I rotated it, remember how I used my L bracket, and I rotated it 90 degrees, it's going counterclockwise, 5, 2. But this new point now, using my, this is about the origin too, would be 2, negative 5. So what do you think happens here? Well, my x value becomes my y value, but changes sign, right? So my x value turns into, or yeah, my original x value turns into my y value, and it changed sign, didn't it? It became negative. And then my y value becomes my new x value. Okay, so that's how I would write the symbolic representation of that rotation. Okay, guess we're to the last one here. Dilations. So dilations is D, capital D sub k, where k is the multiplier on our dilation. So this is, so we'll take the point again, 2, 3, and say I want to dilate to be 3 times as big. So D sub 3 of 2 comma 3. So I use my L bracket, right? And let's say it's from the origin. Going up 1, 2, 3 times as big. So the new point is 3, 6, 9, 2, 4, 6. So it's 9, 6. So the general case is D times whatever constant I'm multiplying by. So this is 3 times bigger, right? So of x and y would be 3 times x, comma 3 times y. Oh, but in general it would be k, right? So instead of 3 it would be k. K times x and k times y. Okay, so that'll get you started, and you have some practices to do with that.